Okay, so hi everyone, and welcome to this ClickHouse and Contentsquare virtual meetup. My name's Elisa Waver. I work for ClickHouse and I'm based in our Amsterdam office. And yeah, we have a really great agenda for you today. First up, we're going to be hearing from Riyadh from Contentsquare, who'll be talking about their journey migrating from Elasticsearch to ClickHouse. Next is Pavel and Francois from Contentsquare, who will be giving us some insights into their CHProxy project. And then we'll have some time for Q&A for Contentsquare, but feel free to also use the chat as we go along and ask your questions and drop your comments in there. And our final talk will be with Alexei from ClickHouse, who's our co-founder and CTO. And Alexei will give us a roundup of the top features from last year and give us a glimpse into the roadmap for 2022. And yeah, we'll have some more time for questions at the end. So let's get started. I'll stop my screen share and over to you, Riyadh.
Okay, thank you. Thanks everyone for being here. We're very happy to share this meetup with you and with the amazing guys at ClickHouse. Today, I'll be sharing an experience report on regarding our migration from Elasticsearch to ClickHouse that we started 4 years ago and how it's been so far. This reports on the work done by my very talented teammates on the data team and the platform team at Contentsquare over the last 4 years. I'm Riyadh Zenin. I'm a senior data engineer at Contentsquare, and today I'm the storyteller. So at Contentsquare, we build tools that allow you to analyze and improve user experience on digital platform. We are mainly focused on enterprise customers, as you can see by the logos on this slide. We were founded in 2012, and today we are over 1,000 employees. On a typical day at the office, we would record 1 billion page views. Our busiest cluster would serve 100,000 analytics queries, and the average response time of those queries executed in ClickHouse is going to be 200 milliseconds. We are running approximately 100 machines today using ClickHouse. We have several clusters. Most of them have 9 shards. We have 2 replicas per shard. We are running ClickHouse on 2 different cloud providers, and we have 4 open regions, which means that we have 8 clusters running in production today and serving clients worldwide. What Contentsquare will provide you, and I'm telling you this to give you more context about our technical challenges and why ClickHouse was a good fit for our use case. Contentsquare is going to give you the ability to analyze the behavior of your users that are browsing your website or using your mobile application through different lenses and different perspectives. So you could be interested, for example, in how they're interacting with your products, how their journey is going, what are the errors that they're encountering on their journey, how they're consuming content, how they're interacting with that new design that you just released. And for each one of these perspectives and for each one of these lenses, we're going to allow you to drill down into very specific populations. For example, you could be interested in analyzing people that came from online advertising, so paid advertising, visited 3 product pages, added a running shoe to cart, went to checkout, had an error, and started refreshing the checkout page in a loop. A Contentsquare user could come up with a pattern like this on the fly, and within seconds, we will be able to give him all the relevant KPIs and impacts and for that population over the last 13 months of data, which imposes on us, and that's why I took the time to explain a bit the context. This imposes on us a couple of constraints. The first one is that we can't pre-compute anything because all of those populations, all of those segments and those perspectives can be defined on the fly by our customers. So as a user, you don't have to think in advance on the analysis that you're gonna run. You can observe something in practice and go to Contentsquare, set it up, and you have your results in seconds. We can't pre-compute anything. Everything has to be retroactive, and we serve that over 13 months of data, which puts the scene. So 4 years ago, we were doing this on a couple of Elasticsearch clusters. So we had 14 of them. Each one of them was running 30 nodes. And we were struggling to make them bigger while keeping them stable. So we had a lot of them. And this imposed several limitations on our company and its growth. The first one is that given that we couldn't make those Elasticsearch bigger while keeping them stable, we were unable to host very large clients with very high traffic in a stable and comfortable way. So if you were to sign a deal with somebody that has too much traffic to fit on your cluster, then you're going to have a hard time delivering quality experience to that user. The second struggle was that as the traffic of our clients grew, some of them would outgrow the capacity that was remaining on the cluster that they're living in, and their experience using the application would degrade. And therefore, we spent a lot of times and ops moving clients from one cluster to another to make sure that everyone is having a good experience. This kept the team busy for several days. Sometimes at nights, we had some on-calls, some stability issues. And this is when we decided to look for another database. At the time, the team looked into a couple of different technologies with several requirements in mind. We didn't want to have any vendor lock-in. We wanted very low latency. We wanted the technology to work really well with disks. Given the size of our data set, it was not reasonable to go for a full in-memory technology. And we wanted something that was stable and scalable. And this is what led us to, after several benchmarks, to give a try to ClickHouse. We started our migration by building a new commercial product to give a try, warm up, try to learn a bit. It took us a couple of months, and this commercial product and this technical endeavor was a success, which convinced the rest of the company that ClickHouse was actually the correct bet. And after that, we started porting all of our endpoints and all of our APIs from Elasticsearch to ClickHouse. It took 11 months. And then we started migrating the clients one by one, and it took us 4 months. On the first phase of our migration, we decided to build a new product to avoid dealing with the burden of the migration at first, learn how to properly use ClickHouse. It allowed us to build automation and to test it in production setup. So Terraform and Sql to correctly build all of our monitoring and alerting stacks for ClickHouse and to get some production experience, although at a smaller scale. Given that we were not exposed to very high traffic on this new product, we also spent some time generating synthetic data sets to try to understand a bit better the behavior of the technology, but it did not replace a large-scale experience and experiment that we did afterwards. On the second phase, what we did was a very classic and iterative process of selecting a bunch of endpoints that belong together, reporting them to ClickHouse, mirroring all the right traffic onto a ClickHouse cluster, replay the queries that were targeting those endpoints, compare results, and fix regressions. We did that in a loop for a couple of months, which allowed us to port all the endpoints one by one. During that time, the team took a couple of decisions that helped us a lot in the migration. The first one was to avoid breaking any API contract. So you might be tempted if you're redoing something to do it better, to improve the API signatures, to fix some quirks and some technical debt that you've accumulated along the way. But we refrained ourselves from doing that, which allowed us to build automation to compare the new system and the old one and spot regressions very fast. So we also invested in automation for data ingestion, replay, and comparison. And we kept the team split into two parts. So we still dedicated some capacity to improve the legacy cluster and the ClickHouse, the Elasticsearch deployment, and build new features on top of it. Well, you pay a price for this for sure, because you have duplicate work. Now you have a team that is porting all of your current API and infrastructure onto a ClickHouse database, and the other one that is improving and building new feature on the legacy one, which was Elasticsearch. But it also allowed us to avoid a stop the world effect, where for several long months, the company would stop to innovate and would stop to ship new features to the customer. So finding that balance between keeping up with the product innovation and keeping up with the feature delivery while doing the migration was key to the success of the project. Once we were done porting all of the endpoints, we migrated the customers with a lot of care, and we did it one by one. So it took a long period. It took between 4 and 6 months to do this, but we went one customer by customer, and the early investments that we did on the automation of non-regression tested allowed us to actually perform all of that migration with 0 regression. And the team was very happy about that. Migrating to ClickHouse got us a couple of benefits. The infrastructure became 11 times cheaper. It allowed us to increase the retention from our Elasticsearch clusters, where we would keep the data for 3 months. We were able to keep the data for 13 months on a select number of customers by migrating to ClickHouse. And the P99 on the queries was 10 times faster. The average was 4 times faster. It also unlocked a couple of innovation on the product. We were able now to serve all the KPIs and run all the queries on 3 months of history instead of 1. We were able to increase and improve our population analysis by adding the ability to, as I described earlier when I was explaining the context of Contentsquare, to segment and to analyze sequential behaviors. We were able to build form analysis modules, and many more. Let's check, are there any questions already in the chat? No, I think we're good. Okay. While doing the migration, we had to adapt ClickHouse a bit to our use cases. And in this part of the meetup, in this part of the talk, I'm going to be sharing the experiments and adaptation that stood the test of time and that are still in production today. So things that we're still very happy with and we keep investing on and betting on. So the first one, when migrating to ClickHouse, we wanted to have as little overhead as possible with our insertions, and we wanted to keep as many CPU time, as much CPU time as possible dedicated to our queries. We did that by building a dedicated Scala component that would embed a ClickHouse local and a ClickHouse client inside of it. And what that component would do is read from a static assignment of Kafka partitions, build the batches locally, optimize them, turn them into native format, and then send them to a designated ClickHouse shard. This saves some CPU on the production cluster. And it allows us to have very little overhead on our inserts. It also means that now the insertion component and the shard are tightly coupled, and every time we have to do an operation to change our schema on ClickHouse, we also have to do an extra release on the insertion component, because the component has to be aware of the schema in order to use native format. This brings some coupling and a bit more overhead on the operations, but we kept that design for a couple of years and we're very happy with it. The second one was that we had to build a query optimizer in Scala to simplify the queries that we sent to ClickHouse. So as I was explaining before, the queries that Contentsquare builds are dynamic. So a user can come up with any kind of segment, any kind of subpopulation that he wants to analyze. And we provide interfaces to build very rich populations, to define very rich population on which you can run an analysis, which means that all the queries are dynamic. Most of them are unique, and most of them turn out to be very large. So we took the decision early on to build an abstract syntax tree in Scala to represent our ClickHouse queries and not generate the strings directly, which allowed us to build a query optimizer on top of this AST, which does a couple of nice things. The first one will be to merge all of the subqueries that are targeting the same local table when it's possible, to simplify some algebraic expressions before sending the query to ClickHouse. And most importantly, and this is key for performance, to propagate the partition keys to all of the subqueries when it's possible and relevant. For 95% of our queries, this does nothing. For the 5% slowest queries that we run, this improves the performance 10x. So we're very, very happy with this optimizer, and we keep investing on it. This was typically a technical choice that stood the test of time and that we're happy with. While in adopting ClickHouse, though, 4 years ago, there was some critical features and tools that were missing and that you would expect from other comparable database ecosystems that were a bit more mature. For example, we had to build the backup tools ourselves to do the integration with Vault for user management. We struggled a lot for a long time with schema management, especially before the 2021 versions, because sometimes the shards would get out of sync with Zookeeper, and when you would do an alter table on cluster, the shard would not register it immediately, so you'd have to connect to each one of them to double check. Given the number of nodes that we have, this is very time consuming, so we ended up building tooling to do automatic schema management. Deletes and updates on ClickHouse are a bit hard and very heavy on the cluster, so we had to build tooling to be compliant with CCPA and GDPR and do managed deletes on our clusters when the load on it is low. We also invested, as I was saying a bit before, on this Scala client that allows you to represent your queries as an AST and to run the optimizer on top of it. And we did some improvement on CHProxy that you'll hear about from my colleague in a couple of minutes. We are still investing some energy and resources into improving our upgrade story with ClickHouse and all the data rebalances when you add new shards. But these are the topics that we're working on. Thank you, everyone. I think that was it. We are sharing a lot of what I was talking about today. For example, all things related to sequential segmentation on our engineering blog. So I'll invite you all to take a look. There will be some very nice and interesting topics about ClickHouse there if you're interested. Thanks, everyone, for giving me the time.
Thanks, Riyad. We did have one question in the chat if you want to take a look.
Let's cover it.
Or two questions now.
I can take. Okay, Guillaume. We are running at a scale where the conversion to native is actually costing us. So we benchmark, for example, and maybe Francois can tell you a bit more about this later. We benchmark using protocol buffer or other more generic formats to do the insertion, and we lose 20%. This is something that we don't want to keep on the table, and we want those 20%, and we are ready to invest and to deal with the complexity. The complexity that comes with it, but this is very specific to our use case, I think, and on most use cases, this might be overkill. Alexei, we could actually share the exhaustive list, I think, of what would be needed, but the most important one and the big difference maker is propagating the partition key everywhere. Sometimes you can also, by analyzing the query, set the distributed group by no merge to the correct value, but you need knowledge of the data set, which we have at the API level, but maybe ClickHouse in the C++ code base doesn't. Merging subqueries that are hitting the same local table is also big for us. So it makes a big difference, but it's also linked to the very dynamic nature of our queries and the fact that we have very little control on what's going to get generated, and most of the time they're very big and very complex. There are several of them, for example, that don't even fit in the query log of ClickHouse because of size.
Okay, just in case, I will repeat. I will tell what was the question. The question was, why do you need this custom AST optimizer on your site? And what shall we do on ClickHouse? What ClickHouse shall do? What optimizations it has to do by itself to make your custom optimizer unneeded. Yeah, and I understood that it contains large amount of domain-specific knowledge, but some of the optimizations, like pushing condition key as much as possible, probably we can improve, and it will help. It will also help. It will also help if you can share some example of your queries. I like these queries that don't fit on the command line.
Yeah, I think we'll be able to do that. We'll come back to you.
Okay.
Okay, I think that's all the questions. Looks like some comments there. Okay, so over to Pavel and Francois.
Yes. Could you re-add stop sharing so we would?
I'll do.
Thanks. Slideshow. Okay. All right. Hi, everybody. Following the database migration that just Riyad has described, we started to use various projects around ClickHouse. And one of them that was very critical to us was CHProxy. And in this talk, we would like to share with you the details and our latest contributions about this project. But let us firstly present ourselves, because on the Zoom we are just a pizza. In fact, we are not pizza. We are. I'm Pavel, data engineer that works at Contentsquare for over 2.5 years. And since the very beginning of my journey at Contentsquare, I actually work very closely with ClickHouse. And eventually I joined the team of Riyad, where we work closely on ClickHouse, even more closely. And this is Francois.
Hi, my name is Francois. I work as a data engineer at Contentsquare. I've been there for 2 weeks. So first of all, let's present ClickHouse at Contentsquare. So before anything, I will give some context about the kind of data we deal with at Contentsquare. So basically, we work with sessions and views. So a session is an aggregation of several views. So here on the left, you can find an example of some columns we store in ClickHouse. So a session number, a session time, a device ID, and so on and so on. So basically, all of this data is stored on a ClickHouse cluster. So for instance, here we have a 2-shard ClickHouse cluster. And basically, our workflows are mainly analytics query. So we perform aggregations on our data. So for instance, a typical query would be what is the average session duration for all the views for a specific date. So now let's imagine that we have the following ClickHouse cluster topology, where we have 4 shards, and each shard is replicated, and that we have 3 applications. Each application would like to retrieve some data, some metrics from ClickHouse. So as it is, each application would need to be aware of each shard if they wanted to implement round robin and spread the load on each shard. So basically, it means that if we were to add one more shard, we'd need to update every application to make them aware of the 5th shard. So basically, we need a proxy. A proxy would be a component in front of the ClickHouse cluster, and the proxy would be aware of all the shards that are present in the ClickHouse cluster. This way, our applications only need to know the proxy URL and don't have to be aware of any shards in the ClickHouse cluster. Also, if we add one more shard, we just need to update the ClickHouse proxy, to make it aware of the 5th shard without changing anything on the applications. So now that we explained the need of a proxy in front of ClickHouse, we will present ClickHouse proxy and give an overview of some features we use at Contentsquare. So a quick list before we dive into we detail it a little bit more. So we use routing capabilities, load balancing, user management, caching, and some other features. So now let's imagine the following scenario where we have three applications, A, B, and C. The first one will need to query some data from the ClickHouse session cluster, while the two other applications, B and C, will need to get some user data. This data will be served through CHProxy. First of all, what we need to do is to define clusters. So here, for example, you can find an example of configuration where we create the ClickHouse session cluster. We specify that this cluster will have two sets of replica because we have two shards and two replica. And also, we specify the user to connect to ClickHouse. Finally, we also add a user section where we define three users, here, application A, B, and C. Each user has a password, so it will help them to authenticate to CHProxy. Once authenticated, the user will be mapped to a ClickHouse cluster and to a specific ClickHouse user. So for instance, here, application A will target ClickHouse session cluster and will use the read-only user to connect to ClickHouse when authenticated. So now, a quick word about routing. So nothing fancy here, but basically, if application A sends a query to ClickHouse proxy, it will be forwarded to the correct cluster. And the same thing will happen for application B and application C that will be routed to the ClickHouse user cluster. ClickHouse proxy also implements load balancing. Let's imagine that application A makes a query. The query will be routed to a specific shard in the ClickHouse session cluster. And if application A executes a new query, CHProxy will probably robin the request to another shard in order to spread the load on the ClickHouse cluster. Oops, sorry. Now, we also have caching ClickHouse proxy. For instance, here, imagine that we add this key cache to the user application A, where we say that the user application A will use the cache application A. A cache is defined by his name, an expiration date, an expiration for the values in the cache. Also a mode, for instance, here we say that the values will be stored in the file system, and also a parameter Grpc that I will explain a bit later. Now, for instance, let's imagine the following workflow where application A makes a query. The first thing that CHProxy will do is try to see is there anything in the cache for application A. There isn't, so I will forward the request to ClickHouse session cluster. After that, when I get a result back from ClickHouse, I will persist it in the cache and I will forward it to application A. Now, if application A executes the same query within the hour, the data will be served from the cache. Same stuff will happen for application B and C that share the same cache. Now, a fancy feature that comes with ClickHouse proxy is the concurrent caching mechanism. Let's imagine that we have the following scenario where two applications, so B and C, execute the exact same query at the exact same time. What will happen is that CHProxy, in order to save resources on our ClickHouse cluster, will only forward one of the queries. Now, two things may happen. If the query takes more time than the grace time, then after the 30 seconds, CHProxy will also forward the application C query to the ClickHouse user cluster. But if the first query took less than the grace time, then the result will be persisted to cache and application C will get its result directly from the cache. So basically, it's a neat feature to save resources on our ClickHouse clusters. Okay, so now some more features that comes with CHProxy. First of all, we have query stripping that are basically useful for security reasons, where you don't want users to be able to pass ClickHouse settings in a query. We also are able to whitelist some IP ranges if we need to restrict access to ClickHouse proxy. And finally, we have two more parameters to add constraint on our users. For instance, we have the max concurrent queries parameter to tell something that like a user can only execute 2 queries at the same time, and also a query cannot exceed a max execution time seconds. So now that we've explained some features we use at Contentsquare in CHProxy, Pavel will give you a small history of CHProxy.
But maybe before going forward, I will just check the chat because I see there's many messages. But I think it's just a discussion. Okay. So yes, let me walk you through the history of the project. The inception of the project happened in 2017, where a company called Verdamedia created CHProxy. Because at the time, ClickHouse had some limitations related to control of the resources, such as max execution time was permitting sometimes to exceed the limit, and therefore the utilization of resources was higher, as well as the max concurrent queries was running on a node basis, so it was hard to control it on the cluster. And so, as Francois showed to you, the project evolved very much, and it has much more features. And big kudos for that to the Verdamedia. Whereas us in 2019, we decided to migrate ClickHouse we decided to migrate from Elasticsearch to ClickHouse. And from the day one on our production systems, we used also CHProxy. It served our needs very well along the way. We though saw that in 2020, more or less, Verdamedia started to drop support for the community version. They did no longer have time. But it didn't bother us because we had all the features that we needed at the time. Although at 2021, something changed that led us to choose different direction and take the ownership of CHProxy and invest in it in 2022. You may ask what's coming next, and so the target is an IPO in 2024. Yeah, but let's put the jokes aside and see what happened really in 2021. That year we realized something. During one of our coffee breaks at the office, we discussed the optimizations of our ClickHouse cluster. So we decided that we will have a look into the resource utilization, various resource utilization metrics. And we happened to check the number of identical duplicated queries, which you can see on this slide. They are marked by blue surface. And this is the evolution over the day. Adding to that, the red surface accounts for the total amount of queries executed on one of our clusters. So clearly we see here that during the working hours, there is many duplicated queries, roughly 25%. We continued our investigations, and we realized that the source of the problem is CHProxy. And in fact, it's the way we use it in Contentsquare. So to illustrate the problem, let's look at this scenario. We have the topology of two replicas of CHProxy, because in Contentsquare, we have the policy that for customer-facing applications, we need to have a high availability. At the time when we started using CHProxy, we had only a single replica. That's why there was no issue at the very beginning. But so let's illustrate the problem by replaying a sample query. Application sends the query to CHProxy. CHProxy looks up into its local file system cache if the result has been already computed. It wasn't, so CHProxy redirects the query to ClickHouse. It gets computed, and after all, flashed into the local cache and returned to the original application. But application decides again to replay the very same query. This time, though, it lands on the replica number 2, and CHProxy checks again in its local file system cache the existence of the item for the query, but unfortunately it's not there. So again, it hits the ClickHouse, and the computation is wasted because it's the second time the same computation. After all, it's also saved to its local file system cache. So we delved into CHProxy to see if we can improve the solution for this use case. And we decided to change the mechanism of caching and de facto enrich it with extra functionality. And that's how we created the distributed cache in CHProxy. Let's have a look again at the former scenario, except that this scenario will be using distributed cache. So instead of having one cache per one replica, we will have one cache for shared across two replicas. And we will replay again the scenario. So application will send the query to replica 1. We will check in the cache if the item was already existing. It wasn't, so we computed on ClickHouse cluster, save it to the cache, and return the final answer to the application. Application again sends the identical query to the replica number 2, but this time the replica number 2 finds the result already in the cache, and so we save the computation power. And this was great. We delved into this code, we implemented it and tested, delivered it to production, and we wanted to observe the results, which are here. And as you can see, this is the same graph that I showed just before, except that the blue surface is completely gone, which is exactly what we wanted. So we are very satisfied. But you know what? It's not yet the best. The best is that you can use it also on your systems, and how to use it is showed here. Depending on your scenario, if you are also in the case where you have multiple replicas, you might be interested in using distributed cache. Currently, it's implemented with Redis, so you will have to have the Redis instance up and running, to which your CHProxy would connect to. The definition of this connection is also configuration based, and it belongs to the definition of the cache. But maybe you are in the scenario where you have only one replica, and you better stick to the file system cache, where the definition you can find here. So I've been talking about file system and Redis, but in fact you might be interested in a different kinds of integrations. And you know what? You could do that. You could help us actually. Because when we were building this feature, we did our best to design it in an extendable way. So what you would have to do is implementing this interface and additionally configuration to potentially, I don't know, adding Aerospike as another key value store, because maybe in your company you have the policy to use only Aerospike. Who knows? So we would be very happy to help you to do it with this endeavor. All right, so we discussed, we presented to you the overview of the CHProxy, the brief history, and the future. And now it's time for the future, real future. So here is our roadmap for 2022. We want to focus on 3 following dimensions: on the reliability by actively handling the reported bugs, issues, by adding the CI operations improvements, such as provisioning Docker images and doing the code audit. We also want to make the access to CHProxy easier. And for that, we are bootstrapping the website with the documentation. And de facto, we did it already today. The website is already on. And later on, we will probably add the tutorials for different scenarios. And last but not least, we want to invest in innovation and supporting innovation, one of which could be a distributed rate limiting, and another one is yet to be found, perhaps by you. So feel free to reach out. And so that's it from us. Summing up, CHProxy has been on Contentsquare production for a long time. It served very well our needs, and feel free to check it out. I will check the chat.
Yeah, there's a few questions in there now.
Yeah, and please read the question before answering.
Yes. Question, CHProxy. In a multi-tenant environment, is it possible to call an API to configure a new tenant? Yes, it is possible. You have actually a feature in CHProxy that is interesting. You can reload the configuration without downtime. This might be also something that you would consider then. We also want to add a query cache to ClickHouse itself. Okay, this is not a question. Question, for security reason, is the cache splitted by CHProxy user, company tenants? So yes and no. Depending on the cache you use, file system cache is split by user, whereas the distributed cache currently is shared. Then to the Guillaume's question. Otherwise, user setting can affect query results for identity looking queries. I think I missed the first question.
It is the same about security when multiple users are doing the same query, but they still can get different results due to some access control restrictions, and it will be insecure to cache the result for one user and output this result for another user.
I see the point, yes. Question, how the result is cached in Redis? I mean, how the tabular data mapped into Redis key value store? So the key of the cache is basically a query along with some metadata of the request, whereas the value is simply a raw byte stream from ClickHouse. It supported both the encoded, compressed stream as well as raw data, non-compressed. For which use cases don't you recommend ClickHouse? Maybe this is for Alexei.
I don't recommend to use ClickHouse as transactional database for your company, operational database. I don't recommend it as a replacement for Redis, but for every analytical use case, I do recommend ClickHouse. But this question is actually for you. Everybody already knows my answer. But I am interested about your experience in Contentsquare. Is there some bad experience with ClickHouse when you try it and it works not quite well?
Yeah, we actually had problems at the time, especially with the upgrades of the schema, where we didn't have yet a lot of experience. While doing the schema upgrades, so altering or adding some column, for instance, if we didn't check beforehand that all the processes and mutations were well finished, it was causing a deadlock, and the problems were becoming bigger. So because we were doing a change on the schema and there was data being inserted at the same time, internally there was a problem. That's something that I think of.
Quite interesting. By the way, what version of ClickHouse do you use today?
It's the 2021.3. Most of the issues were with the 2020 version of ClickHouse, I think 2020.3. I think that you would see diminishing returns if your data, if you have many updates and deletes on your data set. These are heavy. So if your workload, if most of your data is immutable and you have a very small portion of it that needs updates, you can find a way to work your way around it, and you can still benefit from all the power that ClickHouse brings to the table. But if you have if you have to deal with a lot of deletes, a lot of updates, and you have to deal with a lot of mutability in your data set, then it becomes a bit more cumbersome to operate, and you see diminishing returns on with the technology, in my opinion.
Okay, thank you. And a question about CHProxy and caching. So if you have some query with enormously large result, would this result be cached? And what about cache pollution of this large result?
Yes, it's a it's a very right question. Currently, this would be a problem because it's not handled. It's though it was added to the list of improvements. So it would cause problems.
Okay. I hope it will land into CHProxy soon. Otherwise, we are going to implement our own caching layer inside ClickHouse. What do you think about this perspective?
Would it be a cluster-wide caching?
Most likely not. Most likely it will be on every node, so it can duplicate some caching results if queries will be processed on different nodes. But there are many possibilities, like if you have some query with order by something, limit 10, and the next query the same but limit 10, offset 10. Can it somehow reuse the result of previous query? It is not so easy, because for this purpose, we will have to cache intermediate data. But it can be quite interesting.
Yes, but the advantage though would be also with CHProxy that you do not have to open a connection to ClickHouse if the data is already cached in CHProxy.
Okay, so even if you turn down ClickHouse, some queries will be still served.
Sorry, could you repeat?
If you turn off ClickHouse server, do I understand that some queries will be still served for 30 seconds?
Yeah, they will be served for as long as CHProxy is up, obviously, and as long as the query has been already cached.
Okay. So should we move to the next?
Yeah, I think it's right on track for your turn now, Alexei.
Okay. Now you should see my screen. So I will tell you about the new features and the upcoming features. What is new in 2021? What are my favorite features? And what to expect in 2022? So if you ask me what are my favorite features of the past year, it will be very difficult to select. We have plenty of the new features, and I don't even count how many of them are my favorite. I want to ask you, Elisa, what is your favorite feature? If you can pick just one.
Sure. Well, I have heard some users saying that window functions is really something they were very excited about getting introduced.
Yeah, by the way, this is also my favorite feature. Chris, can I answer you? Chris, what is your favorite feature?
I like async inserts. It makes inserting a lot of data easier, much easier.
What a coincidence. It is also my favorite feature. Okay, let's start. I will explain in some more details. Oops. So, window functions. What is the most important about window functions? They work, period. They work exactly as in SQL standard. You can write pretty complicated stuff with custom frame definitions. You can use aggregate functions. You can use non-aggregate functions like rank, row number, leg in frame, lead in frame. And it is available for almost already a year. So enjoy and use it. Also, one of my favorite is support for Sql Json. If you ask me what SQL standard ClickHouse is supporting, it will be difficult to answer because maybe ClickHouse does not support any of SQL standard, but maybe ClickHouse has a support of 99% of SQL something and a ton of extensions on top of that. So what is Sql Json? It is part of SQL standard. By the way, from what year, I don't remember. 2008? No, it was later. So you can just have arbitrary JSON and you have expression like JSON path with some array access, with some indexing, and it also works. Available since August previous year, so also please use and enjoy. This is quite small feature, but some people need it for some unusual reason. It's about configuration language of ClickHouse. Maybe you already get used to XML configuration, but many people don't like XML for some reason. They're asking me, I want to just use another language for configuration. And I usually explain that if you are professional, a real professional, you don't care about in what language you will configure your software. But if you are like some trendy hipster kind of developer, you will find it useful. Basically, you write the same configuration, but in YAML instead of XML. It will look more compact. Just don't mess with your white spaces. This is my favorite for security-oriented feature, full disk encryption. In ClickHouse, you can configure multiple disks in a configuration file. You can have multiple volumes in your file system. And now you can wrap one disk into another encrypted disk. Just specify a disk with type encrypted and another disk that will be encrypted. and the path in file system. It will encrypt file contents with AES-CTR algorithm. You have to deliver the key for encryption. It has support for key rotation, so you can introduce new keys. And data will be encrypted, indexes will be encrypted, primary key will be encrypted, everything. Only file names will not be encrypted, so column names will remain in clear text. And also we have per column encryption for the case when some of the columns just have to be encrypted, like user names, IP addresses. So it is good for compliance. About integrations, my favorite is that now ClickHouse has native integration with Postgres. So if you already use Postgres, you can create tables that will read and write into Postgres from ClickHouse queries. You can even write ClickHouse query that will join Postgres table with ClickHouse table or with MySQL table, because we also already have MySQL integration. You can even create a database in ClickHouse with a PostgreSQL engine, and it will automatically create all the tables from Postgres database that will view to the corresponding Postgres tables. And you can use Postgres as a dictionary source and even more. ClickHouse now has support for Postgres protocol, so it can pretend to act like a Postgres. And you can use your favorite tools like PSQL to connect to ClickHouse. Just enable this PostgreSQL port in configuration file and try your favorite tool. You will still have to write your queries in a ClickHouse dialect. We don't support Postgres dialect. So to summarize, we have Postgres storage engine, table function, dictionary source, database engine, and also we have support for replication from Postgres. So it's like subscribing to Postgres tables and writing table updates to ClickHouse table. Very interesting, but quite experimental still. And about integrations, don't forget that we have plenty other integrations like MySQL is already for a long time, and Hive integration is quite new. It is just contributed and available in 22.1. We have integrations with Mongo, Redis, Cassandra. We have support for streaming ingestion from Kafka and RabbitMQ, support for object storages like S3, HDFS, Azure, and connectors for ODBC and JDBC data sources. But even more favorite from previous year is support for user-defined functions. So now we have at least two variants for user-defined functions. You can create a function as SQL expression and use it in your queries. For example, you can simplify expressions with dictionaries just by defining a new name for it. Or you can introduce a new mathematical function. But if it is not enough, you can plug in your custom program, custom script into ClickHouse. Just configure a function with executable type. Define the types of the arguments, the format, and the script. This script will be run. Data will be piped into its input in the specified format. The script will return the output in streaming fashion, and ClickHouse will read it. There are two options. Executable will run this script every time, and executable pool will run a pool of persistent processes. So what else? We also have user-defined table functions. You can plug in your script as a table with executable engine. It works similarly. You can specify the format and arbitrary number of subqueries, or no subqueries at all. In this variant, it will run your script. The script will generate the data from out of nowhere. And ClickHouse will read this data. It is similarly to file engine, but instead of a file, you have a script that generates your data. This option with subqueries is much more interesting. ClickHouse will run this subquery, stream its result into your script. Your script will process the result and return the data back. How you can use it? You can use it for some complex data transformations. For example, you can train a machine learning model, pipe your data into this model, your script will apply it and return the result. Or you can do something more simple like DNS resolution, or who is data, and so on. So now we have UDFs in ClickHouse, and I like it. Okay, so many interesting features. Asynchronous inserts. Chris' favorite, and also my favorite. So I always told you, and probably your mom always told you, don't do small inserts, many small inserts into ClickHouse. ClickHouse does not like small inserts. Group inserts into batches. You can use Kafka and just read batches from Kafka. You can use buffer tables. You can use your own application logic. Just insert data in batches. ClickHouse like batches. But now it is not necessary. You can just enable asynchronous inserts. And if you have multiple concurrent connections, when every connection inserts some small amount of data, the data from different connections will be combined together in memory into one large batch. You can specify some time period like 100 milliseconds. And you will have not more than single batch every 100 milliseconds. It is also safe. By default, you will get confirmation when data was successfully written after it was combined. So it is like you should always do, but now it is done automatically by ClickHouse. And if you want, you can also enable fire and forget mode when you write your data into ClickHouse without confirmation. If you need to write some metrics from multiple different machines. What is also I have to mention, because if I will not mention, it will be forgotten. Support for Grpc protocol. What protocols do we have inside ClickHouse? We have HTTP protocol, native protocol, MySQL compatibility, Postgres compatibility protocols, and now also Grpc. So what is it for? It has feature parity with native protocol. It has a support for compression, query cancellation, query progress, sessions, external data support. But you don't have to implement native protocol that is not even documented well. So if you write in some programming language that has support for Grpc, and almost every programming language has this support, like Python, Go, Java, Rust. The most simple way is to simply use this protocol. It is more rich than HTTP and slightly more performant. There are some features of previous year that were experimental and not ready for production, but some of them are going to graduate to grown up in the upcoming year. And there are at least 4 of them. Maybe there are more. If you know some good experimental feature and you want us to make it production ready, please write in the comments. But now I have to select at least one to explain. And again, I want to ask you, Chris, what is your favorite experimental feature in ClickHouse?
My favorite feature, but I think also the favorite feature of people in the chat is ClickHouse Keeper, or as people in the chat call it, getting rid of Zookeeper.
Yeah, it is much better name. It is much better to name what you want to get rid instead what you want to get add. Elisa, what is your favorite feature?
Well, I'm just going to copy one of the comments and say the projections feature.
Okay, let's look what I have as my favorite. Projections. So Elisa, Congratulations. What is this feature? It is somewhat similar to materialized views. So if you have a table with some order by key, some columns, and you want to create different representation of the data from this table, like different primary key, so different order of columns, or different some aggregation of data. And you may want to store just subset of columns or subset of records for this representation. If you use materialized view, you have to worry about data consistency. What if you will successfully insert into the table, but data will not be inserted into materialized view? It will become inconsistent. But projections have multiple advantages. First, they are always consistent. Projections are updated atomically with the table. You do insert into your table, and if insert will succeed, data will be also inserted into every projection. Projections are replicated in the same way as the table. You just have one replicated table with multiple projections, and you don't have to worry. Everything is replicated at once. And the most important, projections automatically optimize your select queries. You write select for your table, and if this query can benefit from the existing projections, it will read from projections. This feature is contributed by my friend Amos Bird. It is available for almost half a year, or even more than half a year. And quite recently, we have made that if you enable this feature, you still have 100% green test suite. So it will become ready for production since the next release, 22.2 in February. Another favorite and the most anticipated feature that is still experimental but will graduate soon is support for tables over object storage. What we have already implemented in late 2021, we have improved performance for selects. Now if you compare throughput, it is actually better than for EBS volumes. And latency is slightly worse, but comparable. We have implemented parallel processing on multiple replicas. So even if you have single shard, you can still parallelize your query. And in the next release or in March, there will be a cache for object storage in memory or local disk to also improve latency. As a bonus, we have implemented another type of tables, another type of storage named web. You can export your tables into a web server as a set of static files. So you can publish your dataset to external server and just plug in to your ClickHouse, and it will do requests on the fly. Did you know about this feature? If you did, please write it in the comments. By the way, Elisa, do we have some gifts for the best questions? And
I'm sure we could find a gift to send out. So yeah, give us your best questions, please.
okay, I advise you to write. If you know what it is about, or even if you have used this wonderful feature, please write how did you use it. And you will have a chance to win our wonderful gift.
Yeah, I'd say a cool t-shirt.
Cool t-shirt, like mine t-shirt.
Exactly.
Like this. Okay. And what we will have in 2022. By the way, it is already February. 1 month already has passed. And some features from our roadmap are already available. Like this, Schema Inference. So what it is about? Recently, if you use some integration table function like URL or file, and you have a file hosted on some URL, you have to write data format and data structure, and it looks like this. You have to do copy-paste. I don't like copy-paste. But now, since 22.1, it looks like this. Just write the URL. And you don't have to write the structure. You don't have to write the data format. Everything will be inferred automatically for native format, for Parquet format, Avro, Arrow. Don't be confused between Apache Avro and Apache Arrow. They are different formats, and we support both. And also we support Apache ORC, and everything will be auto-detected. So it is just amazing improvement from this to this. It also will infer schema for JSON and CSV. It works for multiple table functions and for processing inside ClickHouse local. And if you create a table, you can also create it without specifying columns and data types. So if you create a second replica, it will just go and extract the structure from already existing replica. So quite an improvement. And we have more to come. It's quite a big list. I want to explain every feature in many details. But again, I want to ask you, Elisa or Chris, who will be the first? Please tell me, what do you want in ClickHouse in 2022?
I have heard from users the backup and restore is something that they're looking forward to.
Okay, and Chris?
I'll go with semi-structured data, or I assume it means JSON. Okay,
so Elisa, you are more like serious. You are concerned about data safety, backups, and so on. And Chris is more like romantic type of person. He is interested in semi-structured data. It is more fancy feature. Okay, and what do I prefer? Semi-structured data. So Chris, congratulations. Backup, I also want to explain backup, but it's more boring. For backup, the most important that they should be able to restore, and that's it. Nothing to explain. Okay, and for semi-structured data, it is much more interesting. What you will have? You will be able to have flexible columns. So you can have multiple columns in your table, and some columns may have JSON data type. And you will be able to insert arbitrary nested JSONs. The types will be automatically inferred during insert. And if you do many inserts with different schema, the schema will be unified on merges. But it's not like storing JSONs inside strings or storing JSONs inside blobs. It is much better because JSON will be analyzed and split into multiple columns and subcolumns. And columns will be stored in a column-oriented format, just like other columns. And when you do queries for some nested elements, these queries will only read required columns. Let me show you in one example. So I have uploaded one dataset from NBA games. I don't watch NBA. As we have our meetup in Europe, probably it's also not so popular and as in the United States, but still a good example. You can already store your JSON inside string field and use JSON functions. But if you do, the query will spend like half a second. Not so slow, but I always want to do it faster. If you specify JSON data type, you will get two benefits. First, it is much more convenient to query data. Compare this and this. This is so more natural. And also, it is much faster. The query is processed instantly, and you don't have to wait even half a second. You don't have to even blink your eye. It is faster. How does it look? After you upload your data, you can describe what types do I actually have. And you will see some inferred data type instead of JSON. It is tuple of multiple columns, and some columns are inferred as strings, some as arrays, and some as arrays of numbers, and multidimensional arrays are automatically supported. So everything is supported. So to summarize, you will be able to have flexible schema in your tables. You will be able to have some columns with strict schema and some columns in flexible schema in one table. And queries for flexible columns will work as fast as with predefined types. We are targeting for the first quarter of this year, or at least for the first half. We'll see. I'm wondering why I did not anyone mention support for transactions? It is very interesting, even for myself, because ClickHouse is not like transactional database. ClickHouse is not like Oracle. ClickHouse is not like MySQL or Postgres. So why do you need transactions inside analytical database management system? There are multiple reasons. You want to do atomic inserts, even if insert covers multiple partitions. You want to do atomic inserts into multiple tables and materialized views. And you may want to do multiple selects from one snapshot. Let me give you an example. If you have a report, and this report contains a diagram and a table, you want the same numbers in the table and in diagram. And if you have to do two different select queries, you want to do these queries from one snapshot inside one transaction. We already have a prototype for transactions for regular merge tree tables. It is going to be introduced in one of the upcoming releases. And we will have support for transactions for replicated merge tree and even for distributed tables. So it will be quite nice to have. And we have more risky, more experimental, but even more exciting things to do. What is the most unclear, the most unusual? Elisa, please choose one.
I would choose vector search indices, ANN search. What is that?
Yeah, it is so interesting that it will be very difficult to explain. And as one alternative option, Chris.
I like lightweight delete. Will be very useful, I think.
Okay, and what do I want to explain? No, you have missed it. I want to explain what is key value data marts. Sounds interesting. So what it is? You know that ClickHouse is not a key value database. ClickHouse is not a replacement for Redis. ClickHouse is not a replacement for Cassandra. But still there is a scenario when you use ClickHouse to store your data for clients, for customers, for campaigns, and you use this data in some real-time scenarios, like personalization or anti-fraud or A/B testing. You want to create some data sets inside ClickHouse and use these data sets in real time by short key value queries, like give me the profile for this user. How many page views this user has done in the past 24 hours. And now you have to export this data into key value database to serve this type of real-time requests. At least if you have more than like 1,000 of these requests per second. But I want ClickHouse to be suitable for even this use case. because I am very, very greedy, actually. I want to ClickHouse be good for that. And we have these scenarios in some companies that also want to use ClickHouse for that. And it is planned for this summer. And Elisa, what about vector search? It is probably the most interesting, the most research-heavy tasks. So what if you have unstructured data like comments in social media, comments, like pictures or even music, and you want to search for similarity. So I have this image of my car. Please give me 100 of images with a similar car from the database. ClickHouse is not quite good for unstructured data, especially for blobs like pictures and music. But what you can do is to prepare some vectors, vector embeddings. You apply some machine learnings and prepare something like array of 100 numbers. And you want to search for similarity by searching in these arrays. By searching inside 100-dimensional vector space with LP metric or even Euclidean metric. But to do this search, you have to use some special indexes, and we don't have these indexes inside ClickHouse. So is that clear? Did my explanation help you?
Yeah, it's a good starting point. Thanks.
I hope so.
We do have a few questions in the chat as well. I'm just conscious of the time a little bit. I'm not sure how many more slides you got.
Only one.
Oh, great.
Okay, what else? Also, I'm dreaming about support of streaming queries and streaming scenarios inside ClickHouse, like group by on data stream on time frames, support for persistent streams. Actually, I like Kafka. Kafka is not bad, but maybe we can implement persistent streams inside ClickHouse, and how wonderful it will be. Let's discuss how wonderful it will be. And thank you. Let's look at the questions.
I can maybe curate a little bit. There was one earlier question from Guillaume about what is the CPU cost of encryption when you were talking about full disk and column encryption.
Surprisingly, not too big. We have conducted some testing, and the difference was sometimes in a single %, and sometimes there were no difference at all. For what reason? Because the algorithm AES has good hardware support and also good software support. So it can process at least 1 GB per second, but also the data is compressed on file system, and usually data is encrypted, and usually compressed data will be encrypted. It is not so good from security standpoint, because it can reveal some of information. You can disable compression for your tables and enable encryption. and then it will become slower. But unless you don't disable compression, it has almost unnoticeable difference.
Nice, that's good to hear. We have a question from Audric on user-defined functions, asking if it's possible to have a UDF with the same name and the same number of arguments, but with different types of arguments.
Currently not. There is no overloading. You have to configure them by different names, but that's a good idea.
And another question by Yuan on UDFs. Do we already know what kind of limitations are there, like timeouts or data formats or something around that?
You can use whatever data format you want. If you will use something like native, probably it will be the most efficient. But you have to read this native format from your script. And if you will spend a lot of time doing it, it will become not so efficient. So maybe even JSON each row format will be more appropriate. And about timeouts. Yes, we have timeouts. They are configurable. If your script will hang or terminate, we will restart your script. And in this case, we will return error for user.
Okay. We have some questions on the key value data mart feature. One question from Vincent, is it kind of like a light and fast aggregating merge tree?
It is very similar. Actually, there is one feature named incremental data aggregation in memory. It is like materialized view with aggregating merge tree engine, but completely in memory. But key value data marts can be used for other kinds of tables, like embedded RocksDB tables or join tables. So you can, it is not only about table engine, it is also about the protocol. ClickHouse should be able to serve multiple small queries in multiple connections.
Okay, and I think that also answers the question by Ramazan about whether it's kind of like a live view, but I think you did a good explanation. Christoph, the other Christoph with an E at the end, not me, is asking about what is the difference between the key value data mart and the current RocksDB engine?
By the way, hi, Christoph. Nice to see you again. I remember
hi.
We had a good time many years ago before COVID. So the difference is that if you will try to use embedded RocksDB engine for key value requests, you will face the limitation of ClickHouse, that ClickHouse actually has not quite good performing web server, HTTP server, and it will not serve more than around 10,000 of queries per second. I want at least several 100,000 of queries per second, if not millions. And we will have to implement something like coroutine based HTTP server, but I'm digging into too many details.
Cool, and there was one question by Yunbo. I'm not sure what it was referring to, but the question was, does it also work for full text search? But I'm not sure.
What is it? ClickHouse.
Oh, the ANN and the
ANN. It may work for full text search, but sometimes not quite as you expect, because it does not perform search by text. It performs search by similarity. You may enter one search phrase, and it will like rethink this search phrase and give you results about related search phrases. I expect it will work like this. So similar to full text search, but more like some kind of magic.
Cool. I think that was all the questions that we had. If anybody still have a question, feel free to post it or just quickly unmute yourself now.
I have one question regarding asynchronous inserts. When you accumulate these inserts in memory and the ClickHouse server goes down, do we consider them lost at this moment?
Yes, this data will be lost, but this data will be not reported as committed to the client. So you send your insert, and the client waits for answer. Before answer is received, data can be lost, and you will not receive the confirmation for your insert. If you have received the confirmation, it means that data was already successfully inserted. So as long as client successfully get the confirmation, data will not be lost.
Okay, thank you.
I think what that means by this is that the client has to wait for up to 200 milliseconds to get the confirmation, right? But I think this can also be turned off, right? I think there was a parameter, Alexei, right?
Yeah, 200 milliseconds by default. You can tune this timeout. You can also completely disable waiting, and then you will get fire and forget mode. Just insert your data and don't care about everything. It is not by default. By default, it is safe. The confirmation is sent after the data is written to file system. So even if ClickHouse server is killed, data is written.
I have a small question again on UDF. Again, I know. I would like to know if it's possible to consider the fact to have a kind of plugin system like we have in competition or in TensorFlow, where we can share memory pointer or things like that to improve speed.
Mm-hmm.
Because if I want to create a small UDF in C++ or something like that, is it possible to, in the future, to have structure or pointer that can use directly instead of reading input from the standard input and just provide back in the standard output, because it can slow the process and maybe it could be even better to have a pointer or something like that.
Mm-hmm. Yeah, we're considering it. The biggest problem is memory isolation. So how to ensure that your C++ code is safe? So probably you are a good C++ engineer, but still it is C++. And what if another person from your team will come to us and say that ClickHouse has crashed, and we will see some unusual code in the stack trace. But there are options, very interesting options about sharing memory with shared memory mechanism and coordinate with pipes. But it becomes quite heavy to implement. So we'll see.
Okay. Thanks.
Any more questions?
I think that's good. So thank you very much, everybody, for joining today. We would love to see you at a future meetup. Hopefully, we can also start doing some in-person meetups again soon. But otherwise, yeah, we'll definitely be doing more virtual ones.
Okay, and also let's select the best question.
All right. Christoph, do you want to select your favorite question?
I saw Guillaume Savary asked a lot of good questions all the way throughout the meetup.
Okay, and also I want to highlight the last question from Yuan, because he, as Christoph mentioned, he is a C++ wizard.
I'm just going to drop my email in the chat. So if you want to send me your details, and I'll make sure you get the t-shirt. Okay.
Okay, thank you for listening.
Thanks, everybody. Have a great rest of your day. Thank you, Contentsquare.
Thank you.
Bye.
Bye.
Bye.